The first half of what I'm going to talk about is a fundamental flaw in the ongoing discussions. I certainly commend Indiana with this task force opportunity to study these things, because too few folks are really trying to understand the true and total cost of every energy resource. First off, lessons learned from markets. And so each of these subheadings of this slide are worthy of an hour conversation, but let's dig into it. The most fundamental problem we have when you look at whether it's polling or PR releases or even in docket discussions within public utility commissions across the country is there is not enough transparency about what the true and total cost of each energy resource is to be able to take polling results and statements about solar's cheaper than coal's cheaper than X. All this discussion is happening with really selective decisions about what's in the cost. And so LCOE analyses that we've used for decades are just inadequate because they're not factoring in these system costs. And a classic example or two I will share. But I put them into two pots. There are direct subsidies, okay, that do not show up in our utility bills. They're buried in our tax bills. I think everybody knows that. I'm not going to linger on it. It's a tens of billions of dollars a year issue. And there's all kinds of discussion. I hear people say all the time, oh, all fuels are subsidized. Well, Life Powered, which you heard from Dr. Brent Bennett 2 weeks ago, who I work with in Austin, has done detailed analysis of what the return on investment of subsidization is, because it is true that all energy is subsidized. The question is, what's the return on investment? And I think the results of those studies show time and time again that the ROI on fossil R&D is certainly significantly lower than what we have on renewables. I'm not going to do a deep dive today on that. I'm going to leave it alone because I think the less understood area is the indirect subsidization of renewable energy. Okay? Transmission. It's already been talked about. I'm going to show you a specific case study of just how significant that cost is and where it will go. The second is balancing the unreliability or the intermittency of wind and solar. The third is the resilience values. Michelle did a good job of addressing that. I'll save time and not cover that here. But a bottom line, and I think you heard this from Dr. Bennett 2 weeks ago as well, is the higher the percentage of penetration of renewable, the costs start to exponentially increase. And there are reasons for that in the system, and I'll try to touch upon them briefly. So this is a busy slide, and we're not going to go through it all. But it is a great example. I'm from Texas, and so when you move there, I'm not native, so I guess I just am a little bit more free to do this. I'm willing to criticize my own state, maybe more than a native Texan. The reality is that the ERCOT market in particular, and the experience that we have had in renewable penetration, is so often cited in a superficial level as a huge success story. And there's many things that are successful about Texas and the grid, but the story of wind penetration in particular is a cautionary tale, one that every state should be watching. What this very busy slide shows you is that the cumulative transmission build has literally doubled the distribution and transmission component of a ratepayer in Texas. Okay? We spent $9 billion on a renewable build called the Competitive Renewable Energy Zone, CREZ build, to date. And then studies are showing that if we continue down this path of deeper renewable penetration, we'll spend another $14 billion. So we're talking about not small numbers, very sizable investments. Transmission investment is valuable. I'm a utility lawyer. I know its value. But transmission investment driven by the intermittency and distant location of renewable energy is something that's just not in as part of the discussion. Sounds like you all are discussing it. I commend you for doing it because I will tell you, I was there when we were deciding about launching on this campaign, and it was vastly underestimated in Texas, and we're experiencing those impacts now. So, off-peak exuberance versus on-peak reality, a very important issue, okay? I mean, a classic example are the headlines you hear. If you were just reading national news about Texas, you think, oh my gosh, it's incredible. And it is an amazing story that we have penetrated the Texas market so much with wind that there are times of the year where we are, and if you annualize over the whole year, we have a lot of wind production, even more than coal in the first half of the year. However, I think everyone here knows this, the system is not built on annualized percentages. It's built on peak needs. We have to have a system that can sustain itself at peak demand and at peak exposure to natural elements. And the story in Texas is an incredibly cautionary one. And these graphs are scary if you're a utility person, but everybody needs to understand the weight of what we're talking about. This is busy, but you basically can see the blue line is what the power that the market needed, and it cycles like everybody has seen in other charts, depending on the time of day. This is a summer scenario, right? The orange line is the wind generation. The dotted line across is how much wind capacity we have. It's a massive wind fleet, 24 gigawatts, okay, 24,000 megawatts. The average production when we need it most is just significantly lower, in the single digits of percentage. And as Dr. Bennett addressed when he talked about battery storage 2 weeks ago, the gap between wind and solar at peak and what we need is a battery capacity infiltration that frankly can't exist based on current physics and economics. It is a far too simplified story that people keep on thinking that we can battery storage or even energy storage our way out of that problem. And by the way, this was not an isolated circumstance. This is July, this is August. We see it over and over. And that's not to say that these are resources we shouldn't build. I have solar on my house, I've supported wind generation. But we cannot underestimate the escalating cost as we more deeply penetrate the market with these sources. So where Indiana is now is where Texas was really a decade and a half ago, making decisions about really big, weighty, costly things. And I would simply ask, look to Texas and learn the lessons from it. And the lessons will continue to be learned as we hit both colder months and hotter months next summer. So not just Texas, SPP, okay? A really infamous period of time. Michelle showed some examples from what happened in January. Very well known that you had a drop off significantly in wind relative to forecast. This is a slide from SPP. This is a deck they presented. A slide and the comment is just significant. This is a major wind penetrated interconnect. I think everybody knows that. 48%, okay, on December 20th, dropped to 17 in less than 24 hours. Caused major system disruption. If we wouldn't have had coal, nuclear, and natural gas performing at extremely reliable levels and being able to ramp up, that would have been a major system failure. And I can say the same thing about the generation fleet in Texas. Very high performance from the thermal fleet is keeping this story from being a horror story. We can't ignore those reliability things moving forward. This is a very wonky, detailed slide that warrants deep study. I'm going to give you the key takeaway because we have limited time. The highest prices of power in Texas at peak going up to $9,000, okay? Those are no longer driven in the Texas market by when we need the most electricity. They're close to our peak demand, but they're now for the first time this year driven by when wind drops off quickly. Wind is moving peak pricing like we've never seen it before. So this slide and the next slide by the independent market monitor, which is Potomac Economics, tell a very cautionary tale. But punchline before I move to phase 2 is right from IMM, okay? Even though natural gas prices were down this year by 15%, power prices in the Texas market went up 40%. How does that happen? When you underestimate what the cost of renewable penetration is going to be in your grid. So please learn the lesson and continue to study it closely, not because I'm a Texan and I want you to study Texas, but because these are cautionary tales. And Texas, as the only other market that uses more coal generation than Indiana, the only one, is not an irrelevant example, okay? Just a slight retirement of its coal fleet has thrown us into some very dire circumstances. Please don't replicate that model. MIT states, and you saw this slide from Dr. Bennett, so I won't repeat it other than to say that it is a fact that most document that as you escalate penetration, in other words, as you drop your grams per kilowatt hour of power, your costs escalate because of the need to cover the intermittency issue. And that doesn't even factor in the resilience things that Michelle has appropriately pointed out.
Questions? Yes.
Thank you, Mr. Chairman. You mentioned that we are where Texas was 10 or 15 years ago. So what did the process look like in Texas at that time, similar to what we're doing now? And then what steps did they take legislatively or via regulation to get where they are today?
So very importantly, I think most people know this, but I'll state it so everybody's on the same page, because you have a great state, you don't need to really pay attention to Texas. Texas deregulated its wholesale utility markets. So there are no more rate proceedings other than a couple of pockets. That had benefits, clearly. It also stripped away the oversight of a public utility commission to evaluate these decisions on a system-wide basis. So although I've been an advocate for deregulation as a concept, it proves to be very inadequate in terms of system planning. If you're not factoring in that transmission cost, what happens? It's decoupled, and lo and behold, you let yourself spend $9 billion, but that money got socialized to all fuels, and not a single utility had to do a system evaluation about what the dollar per megawatt hour levelized cost of electricity was going to be if they decided to shut something down and build wind, for example. That is a huge miss by us. We recognize it. Don't make the same mistake, please. And that really is the most obvious thing, is that we deregulated our market, we let the wild winds of the market forces flow, and that has rendered some benefits, but the biggest miss, other than transmission, the impact of subsidization. I think you all know this, but when you get $23 a megawatt hour for putting wind on a grid in the form of a subsidy, and the price of electricity drops to low, and you only get that subsidy if you generate, you bid the price of electricity negative. You literally, in the Texas market, see 1 out of every 3 bids negative. In other words, paying to stay on the grid. So that has 2 effects. 1, it destroys and distorts the marketplace, and 2, it erodes the capital of existing thermal, nuclear, coal, and I will tell you gas. We could spend another hour talking about how the myth that new gas is getting built. Take a look at the Texas market. See how much new gas is getting built. Close to nothing, because people and banks are not going to invest in a marketplace where a subsidy is driving the price of electricity to below zero.